Hey there, STEM Chemistry. This is Miss Ruark. We're going to start Vodcast 1.2, where I'm going to give you a basic overview of the periodic table of elements, and I'm going to start showing you how to use it as a big old cheat sheet. Okay, so periodic table of elements. Here, it's organized into rows and columns. Okay, the columns going up and down are what we call groups or families. And that's how we refer to them. And we call them groups or families because all of those in a specific row, with the exception of hydrogen here, but all of those in this first row are going to behave similar. They're going to have similar reactivity when they react with things. All these in this group are going to have similar behaviors. Over here, all these are noble gases. They're going to react similarly, or not react in that case. All right, and then going across, we have our rows. We call those periods. Right? And a new period will start over where we start our characteristics again. And these periods show us the energy levels for all of the electrons that are contained in the atom. So just to give you an idea of what I mean, here's potassium, and it's in the fourth energy level. It's in the fourth row. So that means there are a total of 4 energy levels for potassium. It has 19 protons, and since it's a neutral atom, it has 19 electrons. And so it shows us that we have some in the first energy level, some in the second, some in the third, and some in the fourth. And we'll get into how they're arranged when we get into quantum numbers, orbital notation, and electron configuration very soon. Okay, so here we have the periodic table again. Let's talk about some of the main groups. So group 1, those are called the alkali metals. Okay, it contains all of those in the first group, or the first column, except hydrogen. Hydrogen is not a metal. It's a nonmetal. It's located over here because it only has one valence electron. And you might say, well, what in the world is a valence electron? Well, a valence electron is an outermost electron. It's the one in the outermost energy level. And so hydrogen has one valence electron, just like all the other elements listed here. And so that's why it's there. All right, so alkali metals are extremely reactive. They react very violently with moisture, especially with water. So you won't be able to find any of them free in nature. You won't be able to find just lithium, just sodium, just potassium, because if you did, it would react with the moisture in the air, and we would have huge explosions all over the place, and that wouldn't be good. All right, so what do? They have to find ore, or they have to find it as a salt, and then they will purify it. Okay. All right, group 2. Here we go. Group 2. These are called the alkaline earth metals. Okay. Group 2, alkaline earth metals. These are extremely reactive as well, just not as reactive as group 1, and these aren't found pure in nature either. Okay, these are all in the same group because they all behave similar because they each have 2 valence electrons. Now, these aren't found free in nature, and if you are to go to college, well, you're going to go to college. All right, so when you get to college, you might be able to see them pull out a chunk of potassium or a chunk of calcium. Now, when they pull it out, it's going to look funny. It's a really soft metal, and they can actually cut it with a butter knife. And some of them, it's so soft you can cut it with a plastic knife. It's a soft metal. But they don't store it just, out in the open. They have to store it in I've forgotten what it's called right now. I want to say kerosene, because it's going to keep it, away from the air. It's going to keep it away from the water, and it keeps it so that it doesn't react. It doesn't blow the place up. It's pretty cool too, because then they'll take a chunk and put it in the water, and it just fizzes, and it's cool. Okay, sorry. All right, so here we have group 18. Group 18, we call them the noble gases. They are the noble gases, the royalty of the periodic table. All of the elements on the periodic table are trying to be just like them. They're snobs. They are very stable, and they are inert, which means they don't react. They don't interact. They don't do anything. They're snobs. Okay, and they have a completely full valence electron shell, which means that they have 8 valence electrons. It's completely full. So, because it's completely full, they're not going to form compounds with other elements. Now, there is one that will go and form a compound with other elements, but it's really rare. All right, next one, we have group 17. These are the halogens. Halogens, halogens. And the word halogen stands for salt former. Okay, that means that they're going to form salts. Now, you're most familiar with salt, NaCl. Okay, well look, it's sodium from group 1 and then chlorine from group 2. See, halogens is a salt former, so it's going to form a salt, an ionic compound with a metal. Okay, so when I say a salt, I don't mean somebody beating you up, okay, unless we're talking about salt and battery. But if I talk about salt in class and I'm talking about NaCl, I'll refer to it as table salt because that's a specific type of salt. Okay, and these all have 7 valence electrons in their outer shell. Okay. Then we have groups 3 through 12, and notice how this green line extends past group 12 and it kind of goes underneath the staircase, and I couldn't get it to continue going, but we could continue it going under the staircase, and these are called the transition metals. So the transition metals are any ones in groups 3 through 12 and underneath the staircase. Okay, now you will hear me refer to this group as, this is the swimming pool. Okay, why? Because the periodic table looks like a swimming pool, and this is the deep end right here. This is the shallow end. Here's your diving board, right? And so you're going to climb up and jump off the here's your person. You're going to jump off the diving board, right? And into the water. So here's the swimming pool. It's just silly, I know. Go with me on this. All right, so these right here are all going to be hard metals. They have extremely high melting points, and these are usually the ones that are going to be used to form alloys. Typically, they have 2 valence electrons, at least they should, according to the way that the structure lays out. But these are transition metals, so they can form more than one charge. So you have some that have 1 valence electron, some that have, they'll form a +1, they'll form a +2, a +3 charge. Some of them can go higher, so +4. Okay, and it's all because it just depends on their structure, and we'll get into all that, but not right now. Okay. And then the bottom 2 rows. Oh, it was supposed to show up. I had a pretty little thing it was supposed to show up. It didn't. Okay. The bottom 2 rows down here, we have our lanthanides, which is the first row. It actually starts with lanthanum here. This should be here, and this one should be here, but that's okay. And then the actinides. Actinium should be here. Okay. Those are what we call the inner earth metals. That's the old way of talking about them. Inner earth metals. You can also call them the rare earth metals, and then we could refer to them as a group or as a row, the lanthanides and the actinides. Okay, so how did we get the periodic table the way that we did? Well, a lot of people came together and they were working for years and years trying to figure out how to organize and make sense of all these elements. So this man, Dmitri Mendeleev, he is credited as the father of the periodic table. He's the one that has been given credit for his work on the periodic table, and they say that he's the one who organized it first. He wasn't the one that organized it first. He just kind of got the credit for organizing it first. There was a bunch of people working on it at that time. And I'm actually going to have you read something about it, and it's really, really fascinating. I know, it's nerd stuff. All right, but he organized it by increasing atomic mass. So he put all of the elements in order by their masses. He went from smallest to largest mass. And if you look at the periodic table, it's still pretty much in order of increasing atomic mass. There's just a couple of them that are out of whack. Okay. When he made his periodic table, and this is just one example of a periodic table that he came up with. Okay, you notice that he grouped them. So he has group 1, group 2, group 3, 4, 5, 6, so on. So he did have them grouped just like we do now, and he said that all of those in the same group have similar characteristics and properties. Hey, that's what we say still. All right, but look, he left some blanks in here, right? So he's got a blank here, he's got a blank here, he's got blanks all over the place. And what he said is that he's going to leave those blanks there because those are elements that there's elements that haven't been discovered that should fit in there right now. Okay, so then at the same time that he was doing this, there was a guy named Henry Moseley. This is what he looks like, stuffy old chap. All right, and Henry Moseley was actually working on it as well at the same time, and he kept going on after Mendeleev, and he looked at it and he said, you know, this this needs to be rearranged a little bit more. So he rearranged the periodic table that Mendeleev arranged based on work that people had done before him, and he did it by increasing atomic number. Okay, and if you remember, atomic number is the number of protons. Okay, so that's why it goes from 1 to 118 now, all in order. It's really cool. Okay, so how can we use the periodic table to figure out, well, how can we use periodic table? Well, this is, I like to refer to this as atomic math. Other people say something different. But all we're going to do is we're going to go through this first one together, and then I want you to try these bottom two on your own. All right, so our element is H, which would be hydrogen. All right, hopefully you all know that. But if you don't, you have a periodic table. Okay, I need my pointer. Where's my pointer? Not laser pointer. That's not cool. Okay. Oh no! Sorry, technical difficulties. Okay, so here we have hydrogen, and the atomic number for hydrogen, if you look here, is 1. And the atomic mass for hydrogen, we would round that to 1.008. So let's go back. And we know that the atomic number is 1. Of course, my pen's not going to work. It's going to be a pain in the tushy right now. Okay, let's try this again. Here we go. All right, so there we go. Atomic number of 1 and mass is 1.008. Well, the mass number, we don't know for sure what the mass number is because we don't know exactly which isotope, but we're going to take this mass number and round it to a whole number, so we get 1. Okay, so protons, number of protons should be equal to this number right here, so we'd have 1 proton. How many electrons do we have? Well, it's a neutral atom. How do we know? Because there's no plus or minus, so we put a 1. And then to figure out neutrons, if you remember from the last one, we take mass number, and this is protons plus neutrons, so we would subtract it. 1 minus 1 is 0. Okay, I want you to try that and see if you can answer the next two. I know there's pluses and minuses. Oh no, it'll be okay. We'll cover it in class to make sure that you've got it. Okay, I got a cute little video here. Let's see if it's going to play. Oh my gosh, it's probably not going to play. Okay, here's going to play. All right, there you go. Okay, and we know that these have been discovered and named. All right, so that was just a nice little song to leave you with, and here you go. I'll see you in class.